Good evening, ladies and gentlemen. My name is John Case, and today I'm going to be talking about my senior project. That's not good. Sorry about that. My senior project, which is a mountain bike rack that that I designed and built. Okay, so let's start things off here. It's going to load. Okay. All right, so my motivation for building this mountain bike rack as being an avid mountain biker, I don't know if anyone has tried to lift a 42-pound awkward shaped mountain bike on top of a vehicle, but it is very hard to do, especially after a long day of mountain biking. Bikes can weigh up to 50 pounds, so I originally had a rack on the top of my car that was similar to the one that you see in the picture. It's designed for a 35-pound bike, and it failed while I was going around the corner. It held the wheels in place, but it ended up pivoting my bike into the top of my car, so that was just not good. So I wanted to design a mountain bike rack that would not touch a car in any way. The rack in general, you can't really see the dent in this picture, but the rack in general actually put these dents in my car. So I wanted to design a rack that fit into a 1 1/4 inch hitch receiver, which I had in my car, would hold 4 bikes, and I wanted it to be able to assist the user in lifting the bikes up into the upright position. Also, I wanted it to be light enough for one person to carry it and take it in and out of the hitch. Let's see here. Okay. So this design that you see here, there's a company, NorthshoreRacks.com. I actually talked with them, and they were very happy that I was actually going to design something like this. They actually hadn't ever thought of a rack that would retract to assist in lifting the bikes up. Well, let me scroll down. Well, actually, let me talk more about this, because you have to lift each individual bike up in the air with the handlebars and the front tire skyward to put the crown of the fork in each individual slot that you see on this and my rack. So I designed it, but before I did that, I wanted to have some engineering merit. So I wanted to create a spring that would assist the pivot of the rack. And so this is, oh, actually, let me talk about this one. This right here is determining how thick of material and what kind of material I need to buy. I did that by doing a deflection equation to make sure that 4 50-pound bikes weren't going to put the material past its yield. And then this equation right here was to find how much lifting force the spring would need. I'll talk more later about the spring, but ended up only needing a 320-pound pull for a spring. Let me actually click on this because it has kind of a terrible picture in here. So this is, might not come up, but I can show you here. This is my SolidWorks drive of the mountain bike rack that I wanted to design. Very pixelated, but here's the spring. And it just would be simply attached to the 2 pieces, pivot right here. The 2 pieces would be attached with the eyelet joint. Let's see. All right. It's a very simple bike rack design. Here's the drying tree for it. There's only about 4 parts, one of those including a bolt. So it's not terribly, hard to construct, which made it quite nice. Here's my schedule, and then I also have my testing schedule below it. I actually followed the schedule to a T and made any revisions to it if they came up. Okay, so construction. So first, before I keep scrolling down, I'd like to talk about spring. I wanted to wind the spring myself because it was a very heavy-duty spring that was required. It needed thick spring steel, and unfortunately we didn't have a big enough lathe or a big enough guide to wind the spring with. Gear Essentials. So many options were thought of, and someone mentioned to me that a bungee cord would be a good option that I found actually on eBay. So ended up buying a waterproof UV protected bungee cord. Here's me stretching it. It stretches twice its length at 400 pounds. I thought that that would be enough to include just one bungee cord in place of the spring. But later on, after in the construction stage, I found out that 2 was more suitable, especially with 4 bikes on it. All right, so here's some construction pictures. The construction was very straightforward. It was basically, I've done this quite a bit in the past, so it was just pulling off dimensions, cutting to the dimensions, drilling holes where they needed to be drilled. Hardest part was drilling the top notch so that the 2 tubes would line up. I built full gauges, so it wasn't too terribly hard. I have all the tools at my house. I didn't need to do anything here at Central, which made it extremely convenient. This is the bottom pivot joint on the top T of the rack. I knew it needed some reinforcement, so this isn't reinforced. Let me actually scroll down a little bit, but if you can see on either side I had to weld extra pieces of steel so that there was more metal that the pivot bolt was touching. The reason why I did this is because if you have 2 bikes on one side and 1 bike on the other, there's going to be a moment, so it's going to want to twist that bike rack, especially if you're going around the right corner, you have more weight on the right. So that piece meets up with this, which is the base. This is a 1 1/4 inch hitch receiver style tubing, and the unfortunate thing about the company that I bought all the steel from, I called and they said that they had a thicker material in stock that would fit in a 1 1/4 inch hitch receiver style receiver, and I got there and it didn't fit. It actually had tighter corners, so I ended up having to go with this, which is a 1/8 thick steel bar. And so due to having a thinner material on the base, the point right here where the pivot bolt goes through ended up being not quite enough steel. I'll talk about that in the conclusion though. Okay, so like I say, it went quite efficiently. It was fun to design and it was very fun to construct. Now for the testing stage, and I'm not going to lie, this was kind of nerve-wracking because my test was more or less a pass-fail. It was, I built it, it should hold 4 bikes, and this is what should go, and it, well, let's talk about it. So here's my schedule, and as what I ended up doing as a safety factor is I used sandbags as weights for bikes instead of actual mountain bikes, which are quite expensive. So let's scroll down. Here we go. Here's 2 sandbags. I just simply strung them over the holders. Each of those were 45 pounds each. Got 2 90-pound bags. And then here's the rack with 4 sandbags on it. And I don't know if you guys can tell from the pixelated picture, but it is leaning to the right. And this was after I put all the weight on it and gave it a good shake from side to side. I wanted to make sure that it would hold. It did hold, but from viewing its off-camber, I deemed it as unsafe for 4 bicycles at the moment. And I think that, well actually, I know from inspection that the pivot joint that I talked about earlier had elongated. It kind of egged out due to the fact that the steel was too thin. I couldn't get thicker steel. So that was kind of a bum deal. Although it is a very easy fix because all I need to do is buy more steel and reinforce it. I just haven't done that yet. Okay, so improvement. Here's a close-up of the joint that I've been talking about. I don't know if you can see this hitch pin right here, but that's to lock the rack from folding up and down. And here's all my costs. My total predicted cost for the rack was $78, and I ended up spending $127 on it due to the fact that I had to buy a bungee cord and a few other little odds and ends like drill bits. My labor was right on. I predicted at 120 hours, and I was at 122 hours. I literally followed my schedules to a T. And if anyone wants to replicate the rack, I have all of my drawings up on my website, and the spring, just in case I ever do have a big enough lathe to construct this spring. And here is my full schedule in hours. And here is a short video of how the actual rack works. Let's see if it will open here. Open, no, nothing anywhere. Okay. And play. Turn this out now because it's not good. Oh, I'm so sorry about that. That's not good. So this is the rack folded down. You simply have to get the bike in the correct position on the fingers, is what I call it. And then you lift the bike. It helps to have two people to lift the rack on either side. It goes all the way up like that. That's exactly how the bike's supposed to look when it's up. You throw the hitch lock in the base, slides through, thing goes in. That's it. And I also have a little bungee cord that I wrap around the rear tire so it doesn't flop around. Are there any questions?
You do pretty well with one.